Well, hello again. In this video, we're going to look at our second rule for dealing with exponential numbers, and it's going to be entitled the quotient rule. So the quotient rule reads like this. When dividing exponential expressions with the same non-zero base, subtract the exponent in the denominator from the exponent in the numerator. Use this difference as the exponent of the common base. Once again, it's all about having a common base. You must have both being base 2, both being base 3, both being base whatever. You may choose your base. Now, here's the way it's stated in algebra. And this part right here, a lot of people want to leave off, but that is very critical. That is the part up at the top that said the same non-zero base. You cannot have 0 in the denominator because the first commandment of algebra is thou shalt not divide by 0. And if b is 0, you've got a 0 in the denominator and you've got something divided by 0. So be sure that you're not allowing for that to be 0. Now, in numbers, so far this has not had a very important part to play. But when we get to having variables in those denominators, you are going to have to specify what will make that denominator 0 so that we don't accidentally let it happen. But it's just like with the multiplication rule. All I had to look at was the m and the n. Again, since I have a common base, I'm still just looking at the m and the n, but this time I'm subtracting instead of adding, because when you multiply, you added, and division's the opposite of multiplication, and the opposite of addition is subtraction. All right, let's take a look at an example. Divide using the quotient rule. Now, Miss Harold didn't give you one of these really easy first year Algebra 1 steps in this one. But we're going to do it exactly like we ended yesterday, and if you did practice it enough so that you could do it without having to break it down, then you could probably jump right into this one. But since we're not quite ready for some of us to jump into it, I am going to break it down. And I'm going to call that division multiplying by the reciprocal so that I can multiply in any order I want. And here's the order I want. I'm going to break it down so that I've got my like variables together. Now I've got 3 separate quotient problems. The first one's not a big deal. That comes from elementary school. 35 divided by 7 is 5. The next 2, they're both using the quotient rule. When you have a common base of x, the common base of x will be in your answer. Then you subtract the exponents, top minus bottom, numerator minus denominator. So 5 minus 3 is 2. The next guy has a common base of y, and 8 minus 2 is 6. So this is my final answer. Now again, we want to get to the point to where we can leave out this middle step. We want to skip him altogether before we actually get into the college algebra curriculum. Practice it until you can. So here we go again. Again, what I think, even if I don't write it, is 54 divided by 6 is 9. Then I look at 8 to the 7th over 8 to the 3rd, and that's just all I'm looking at, and I say base A, 7 minus 3 is 4. Then I look at the b to the 12th over b to the 5th, and that's a common base of b, and 12 minus 5 is 7. So 9a to the 4th, b to the 7. If I break it down into 3 simple problems instead of one big problem, it becomes very easy. But again, I want to do that part in my head. Okay? Now, This says divide using the quotient rule, but Miss Harold, don't you have to have a fraction? Well, guys, you do have. Right there. That divided by sign, I'm going to write algebraically as a fraction bar. And then we're going to try to do this one without writing it out. So I hope you're still with me. 42 over 7 is 6. I see x's, which have a common base x. Exponent 7, exponent 4. 7 minus 4 is 3. Then I'm going to deal with my y's. Common base y, 9 minus 6, also 3. Final answer, 6x cubed y cubed. Again, break it down into individual steps and you'll find that it'll be much easier. Good luck. Practice it until you're good at it.